The kill zone is a phrase often associated with high-risk driving, but it can describe any scenario that creates an emergency for the driver. The scenario can be driving the principal to the office or taking him or her to a venue. Anytime the principal is moving in a vehicle, there's a possibility of an emergency scenario. What we will learn is that kill zones are not subjective. They are a science. Escaping them, understanding them, and then avoiding them is simply based on the laws of physics. But no matter what the scenario, an emergency/kill zone is a time-distance relationship. How much time you have, how close is the problem, distance and time. The kill zone is directly related to the speed of the vehicle when the incident occurs. If you have a lot of time and distance, in reality, you don't need a lot of driving skill. The less time and the less distance, the more skill behind the wheel is needed. As time and distance decreases, skill level needs to be increased. Measuring kill zones. While driving, you are managing time and distance. Time and distance is measured using a familiar dashboard instrument, the speedometer. The following is a simplistic but necessary explanation. A speedometer measures miles per hour, the time it takes to cover a given distance. It's a natural unit of reference that every driver is familiar with. The problem is that using the speedometer as a frame of reference for defining time and distance, hence kill zone, is simply not usable. We need to have the ability to measure time and distance in kill zones in a different unit and a different frame of reference. We need to be able to convert miles per hour to feet per second. As I mentioned, we need to understand the concept of the kill zone, and to do that better, we must convert the standard unit of measurement, miles per hour, to a more practical feet per second. It's not about how many miles you travel in an hour, but rather how many feet you travel in a second. Emergencies, including vehicle violence, do not take an hour to happen, and the space in which it occurs is not measured in miles. If a driver diverts their attention from the driving task, such as takes their eyes off the road, when their eyes return to the road and there's an accident or an attack scenario in front of them, they do not have an hour to react, and the space won't be measured in miles. They have mere feet and seconds to get out of the kill zone. At this point, there is a fine line between the time and distance that defines success and failure. Making kill zones easier to understand, this is going to require some math. We need to convert miles per hour to feet per second, and here's how it is done. There are 5,280 feet in a mile and 3,600 seconds in an hour. To convert miles per hour to feet per second, we divide 5,280 feet by 3,600 seconds, which will be 1.47. The laws of math allow me to round the 1.47 to 1.5. So for every mile per hour you travel, you move 1.47 or 1.5 feet. If I'm driving at 10 miles an hour, I cover 15 feet in 1 second. If I'm driving 20 miles an hour, that would be 20 times 1.5 or 30 feet in 1 second. 40 miles per hour would be 40 times 1.5 or 60 feet in 1 second. 60 miles per hour would be 60 times 1.5 or 90 feet in 1 second. There is an easier way of converting miles per hour to feet per second. It is nothing but a simple math trick. You take half of the speed and add it to itself. So, if you were going 50 miles an hour, you take half of 50, which is 25, add it together, 50 plus 25, you would be traveling 75 feet in 1 second. If you were traveling 70 miles an hour, half of 70 is 35, 70 plus 35, So at 70 miles an hour, in 1 second, you would travel 105 feet. If you were traveling 90 miles an hour, half of 90 is 45. 90 and 45 is 135. So at 90 miles an hour, you would be traveling 135 feet in 1 second. Let's quickly examine NASCAR drivers. They're going down the straightaway at 200 miles an hour. Half of 200 is 100. 200 plus 100 is 300. So at 200 miles an hour, they're traveling 300 feet, the length of a football field, in 1 second. The 2.5 second rule. Research conducted by Dr. Marc Green indicates the average driver needs 2.5 seconds to react to a problem. Using this 2.5 second rule, let's take a look at the distance needed to avoid problems at various speeds. If you're traveling 40 miles an hour and you're moving at the rate of 60 feet in a second, in 2.5 seconds, you would need 150 feet to react to the problem. You got that number by multiplying the 60 feet per second by Dr. Green's 2.5 second rule. At 60 miles an hour, 90 feet a second, in 2.5 seconds, you travel 225 feet before you would react to the problem. At 80 miles an hour, you'd be traveling 120 feet a second. Multiply that times 2.5, you would need, at 80 miles an hour, 300 feet, the length of a football field to react to the problem. That is if you're average. So what does this mean? If you were driving 40 miles an hour and an accident or an ambush scenario happened 140 feet away from you without any training and being the average driver, you would not be able to avoid the incident when stuff happens. To repeat from the last slide, at 40 miles an hour, you're going 60 feet a second. You would need 150 feet, 60 times 2.5, to react to the problem. So, if there is a problem 140 feet away, life's going to get pretty exciting. Whoever is driving the car at that time can't be average. Being average can kill you. How do you know the level of skill the driver possesses? The hell of a time to find that out is when bad things are happening in front of you. The driver-vehicle combination is a measurable skill that can be measured and enhanced through training. If you have been to a driver training program, that number has not been measured. It is problematic. You need to know what the skill level of the driver is. In the blink of an eye, most all can recall a traffic incident where the difference between having the accident and not having the accident was measured in less than a foot. I'm going to ask all watching this to do something simple for me. Blink your eyes. I literally want you just to blink your eyes. Blinking your eye took 0.2 seconds. So if you were going 60 miles an hour, which is 90 feet a second, in 0.2 of a second, you moved 18 feet. If you were going 40 miles an hour in 0.2 of a second, a blink of an eye, you went 12 feet. At 80 miles an hour, 0.2 of a second, a blink of the eye is 24 feet. The difference between success and failure is razor thin. What I meant by that is that in a blink of an eye, 0.2 of a second can mean the difference between success and failure. If you were moving at the rate of 40 miles an hour and there is a kill zone 180 feet in front of you, the average driver will take 2.5 seconds to react to the kill zone. Let's take a look at how this scenario will play out. Let me restate. Kill zones are a time-distance relationship. Let's play out this scenario. At 40 miles an hour, you're traveling 60 feet in a second. The average driver will use up 150 feet just to react to the problem. We got that number by multiplying the 60 feet per second that you're moving at 40 miles an hour times 2.5 seconds. So, again, let me repeat. The driver will take up 150 feet just to react to the problem. So if we started off with 180 feet and it took the driver 150 feet to react to the problem, that leaves us 30 feet away from the kill zone, still going 40 miles an hour. The key phrase in that last slide was 30 feet away, still going 40 miles an hour, 60 feet a second. 30 feet at 60 feet a second tells us that we got a half a second to do whatever it is we're going to do to avoid that problem. Nothing good is going to happen from this. For the average driver, this is going to be a disaster. Let's look at the same scenario, but with some different numbers. Through training, the driver has decreased their reaction time from 2.5 seconds to 1.5 seconds. The speed is still 40 miles an hour, which is 60 feet a second. So at 40 miles an hour, 60 feet a second, times 1.5 seconds, the driver has used 90 feet to react to the problem. This scenario is easily accomplished. The difference in the two scenarios is the difference that 1 second makes. That 1 second decrease in reaction time gave the driver an extra 60 feet of maneuvering distance. In that 1 second, the scenario has gone from a disaster to doable. Even if the driver is average, how valuable is time? Well, from a previous slide, we mentioned that the blink of an eye takes 0.2 of a second. In the original scenario with the average driver, we came up with the number that they would be 30 feet away from the kill zone if they were driving 40 miles an hour in their average. If they could react a blink of an eye sooner at 40 miles an hour, that would be extra 12 feet, and they now would have a total distance of 42 feet. If they were 2 blinks of an eye quicker, would give them an extra 24 feet, and the driver would be 54 feet away from the kill zone. In a blink of an eye and 2 blinks of an eye, they have gathered a sufficient amount more maneuvering room. What are the takeaways from this presentation? Kill zones are a time-distance relation. That's simple. How much time do I have? How much distance do I have? All relates to how fast you're going, and it is a science that is in accordance to the laws of physics. Keeping in mind, literally, tenths of seconds count. Again, from one of the PowerPoints, at 40 miles an hour, 60 feet a second, a blink of an eye is 12 feet. Tenths of seconds count. Every time you approach a kill zone, understand the parameters. How far can I see? How much distance do I have? If you stop in the kill zone, the chances of survival are slim. That is not speculation. That is taken from historical information. I know this is repetitive, but it literally can mean the difference between life and death. Never drive faster than you can react. Hope you enjoyed the presentation.